Alright guys, thanks for joining here. I'm going to go over the NSX-V Load Balancer and specifically um, just talking about the difference between the inline and one-arm load balancer because I find that there's some aspects of that confuse people. Reason being is that there's a inline load balancer in the sense of architecture, and then there's inline in the sense of configuration, and it's not the same. And same with one-arm topology. You have a one-arm architecture and a one-arm configuration. And just because if you should have your architecture match the configuration, but I find that a lot of customers that I see using this, they will sometimes mix and match, and it causes problems when you have an issue with an application, say, or a load balancer where you have a lot of servers being load balanced. If you have a problem and you need to troubleshoot it, trying to get a customer to explain to me what their architecture is, what very few do I actually have that can explain it. So I wanted to make this video to try to cover that for anybody else who finds himself in a position of administering NSX-V. So let's just go. I think so. First, I'll talk about what I'm viewing here. This is the administration guide on page 317 for NSX-V. I'll put the link in the description below. But let's just take a look at the phases here. So you have phase one where the user makes the request to the server, or in this case it'll hit the load balancer. There's a destination NAT performed. The source NAT is left unchanged, and this is again for inline load balancing. And so the request hits the server responds, and the reason why it's called inline load balancing is because the packet is in line between the user making the request and the server doing the back-end processing. Uh, and that's kind of where you get the inline naming convention from. And the one thing so this is the architecture. I want to briefly segue over to the lab that I have before I really get into what I was going to show you on that screen. Let's go to that particular, or the particular edge I have set up for the lab, which is this load balancer here. We can talk about where I'm getting this distinction between the architecture and the load balancer, or architecture and configuration. So for every server pool, I only have one here, but you can have many server pool or load balancer pool. If you edit it and scroll down, this little button here will be the distinction between inline and one-arm load balancer. So currently, the architecture we just went over was an inline load balancer. In that case, you want your server pool to match that in configuration by having this enabled. Okay, we're going to keep it disabled for the time being because I'm not ready to make that change. I'm going to cancel, but I did want to show you that as we go over the architecture. So next is going to be the one-arm load balancer. We did look at the configuration for that. Let's just take a look at the architecture briefly in the documentation. You see you have phase one where the user makes the request. You have phase two. In this case, you have a destination NAT and a source NAT happening at the same time. And the reason why you have a source NAT is because when the server receives the request to process, it's going to perceive that that packet has come from the load balancer. So then when it goes to deliver what it's generated from the server request, it will send it back to the load balancer. And that's how you get the behavior there. And the reason why this would be called one arm, because usually in this type of load balancer, there's only one interface attached to the same segment as the virtual machines in the server pool. So that's from an architecture standpoint. Again, we went over the configuration aspect of this, and the reason why it's important to distinguish between the two is because even if you have one particular architecture, which in my case I have a inline architecture, it'll work with both transparent configuration and one-arm configuration, and it's important to distinguish those because the type of packets that you see going back and forth are going to change, and then if you have to troubleshoot something like this, there's, as you saw previously with the architecture, the natting is going to be different. So the type of packets that you'll be looking for to troubleshoot any problems are going to be different, and that's my main reason for covering this. And also, it'll probably help those of you who will be deploying it, but administration and troubleshooting also, this can be beneficial as well. So let me quickly just go over the architecture or configuration that I have. So I do have, this is the load balancer as seen from the vSphere vCenter inventory. You can see, and I am using the older interface, but I find it a little bit more reliable and a little bit more, well, I have all of the buttons that I need. I know this is going to be expired by the end of 2020 here, so hopefully by the time you're watching this, you're not using it, but it is good to go back to on these older versions of NSX. So we got a web tier, we got a transit tier, and this is where the load balancer interface is actually going to be situated on this load balancer. And just to show you that, it is this interface here. The load balancer is load balancing for 172.16.0.10, and I can show you that. Open it up in a new tab just to show you that it is live, a live 3-tier app. Okay, so it's loaded again. All right, so the app's going to hit the web tier. Well, first, for the user, which is my desktop here, as I just showed you in the previous, on the other tab there, it's going to hit the load balancer. The load balancer is going to send it to the web tier. Web tier is going to communicate with the database tier and then the app tier. So that's the overall view, and we're going to go back and forth between, well, I'm going to keep the architecture the same, which is it's an inline architecture, but then we're going to do a packet capture and see how the packets change on the back end, and that's really the point of this video here. So let's go take a packet capture. I actually had one running still, so this is at an ESXi host level. If we take a look, we see this load balancer is running on host number 3. And I've already had the packet capture command prepared in advance. I've been working on this lab for a little bit of time before I recorded this, so let's do this first. I'll show you the interfaces. So these are all of the interfaces of the load balancer. All right, the outside interface where the load balancer is listening for requests from the user is going to be on this interface here. All right, so remember that 4.9, and then 4.8 is where the web tier is going to be. So I'm going to packet capture on this here 4.8, and that's where you should see the difference of the source NAT will be happening or not. So in our current case, we should be getting a source NAT. So let me packet capture. And how do I know we should be getting a source NAT? When we looked at the architecture, it said that anytime you have a one-arm load balancer, you should get a source and a destination NAT. All right, so we'll go to the configuration, make sure that matches. Server pool, edit. All right, we scroll down. We have a one-arm load balancer because transparent is disabled. So we're packet capturing now. Let's make a call to this server through the load balancer. We should get some packets flowing. Okay, so we got packets flowing. And as you can see, while I'm at it, what's my IP address? So you can see I'm coming from 192.168.110.10. And you can see this is the interface of the load balancer. It's acting as the default gateway for the web tier. And let's verify that. In settings, interfaces, you can see here. Okay, ignore this naming convention. I had to make some modifications to the lab. I guess for transparency, I am using one of the HOL labs, but these labs get changed every year, so but maybe it's the case by the time you're watching this that this lab no longer exists in the current configuration. It's also the case that I've made some modifications to the lab, as you'll see if you try to load this. So ignore the name, but we see here, this is the interface that we see our packets requests coming from. So this is the source IP address going to uh, server pool or server and the server pool.11 at port 443. And I believe here, if we look at the, yeah, uh, so access via web O2. Interesting. All right, did my lab break? Let's see. I think my lab might have broken. Nothing like a little bit of live troubleshooting here. Yeah, okay. So I think this is just due to the fact of it being a lab and me making some changes to it, but I have seen this happening, which is kind of odd. So if you care to try something similar, but maybe you'll have the same issues as me, and maybe it'll just be something to look at if you actually are troubleshooting a real NSX environment. So let's see if that made a difference. Okay, not sure I follow why that was giving us trouble, but it seems to be working again now. Interesting. All right, well, a little bit of a hiccup, but we'll keep going here. So I think the main thing I just wanted to show you the difference between this transparent and not button. This is the configuration that will make the distinction between a one-arm load balancer and an inline load balancer, and to confirm for you that we do have a one-arm load balancer currently. So we'll run that packet capture one more time. Send a request through the load balancer. Stop the packet capture. Again, you see that this interface is the load balancer interface, so it's been source natted and destination natted because we sent the traffic to 172.168, excuse me, 172.16.0.10. So, right, we have a source and destination NAT here, and everything's happy. No problems there. But let's change the configuration here. The architecture is still the same. I'm not going to move around any interfaces. I'm not going to attach them to anything differently. All I'm going to do is throw this switch here, and now make this a transparent load balancer. And it usually takes some time to switch over. It's not usually a configuration change you'll make on a production environment, so I mean it's not something we would expect to instantly change. And what I found, it doesn't instantly change. Usually, what I do to speed it up is to turn the virtual server off and the load balancer service off, and then turn them back on. All right, and from the end user perspective, it doesn't look any different. Right, the service will still load exactly the same, but on the back end, it'll be Well, it'll be different enough that it's noteworthy if you ever have to work on fixing something like this or deploying it. Right? It gives you an idea of what you're going to be rolling out if you have to implement something like this. Okay, so that's been changed. Let's see if we can load the server. It'll take a few minutes to come back online. Let's packet capture. No, it didn't take that long. All right. So I want to create some separation on this packet capture here, so it's clear where the first packet begins. So we've changed it now to a transparent inline load balancer. Let's make the request. We got the response back. It looks exactly the same, but then when we go to the packet capture, that's where we're going to see the difference here. So here you can see that's my IP address, which we pulled up in the command prompt. And since this is already on the back end, right, it's going from the load balancer to the server pool. There's no source net has happened here, and then the destination net has still happened, which we expect. And port 443, they do their communicating. You can see, same as before, that the tiers all communicate with one another in whatever fashion is needed to provide what the customer is wanting to receive, what the customer is requesting. But it's this change in IP here that's the big thing that I wanted to call out. That hopefully just makes a distinction between these two, between the two architectures, and then the fact that just because you have one architecture or another, that's not enough to actually, if it's not enough to implement an inline load balancer unless you know what the proper configuration is to go along with that. And too many times I've seen different users of this product that don't really see that difference. So this video is just here to explain it. Again, you have the one arm and inline load balancer from an architecture standpoint, and then you also have to have the corresponding transparent button uh, configured appropriately here. And I've demonstrated that with some packet captures how that actually plays out. Hopefully this will help somebody if you're troubleshooting, or even if you just want to understand how the load balancer is working with NSX. And that's it. So thanks for your time.